Assalamualaikum warahmatullahi wabarakatuh. Hello honorable judges, my name is Najwa Azizah Ismail. I'm a senior high school student from SMA Pribadi Bandung. In this opportunity, I would like to present my project with the title of Modified Greenhouse with Microparticle Water, Ultrasonic and Arduino Microcontroller. Indonesia is an agricultural country with a lot of germplasm for the availability of food for its residents. Increasing global temperatures and erratic seasonal changes, such as prolonged dry seasons and unpredictable rainfall, significantly impact on crop failure. As a result, the food supply will decrease and reduce people's nutrition. The low production of vegetables in Indonesia can be caused by several reasons, such as the application of simple cultivation technology or because the land for farming is decreasing. Quoted from Kompas TV, President Joko Widodo said that tens of thousands of people per day in the world die because of the food crisis, and he emphasized that the crisis may occur in the long term. The United Nations stated that the climate change has threatened the world's food supply. More than 10% of the world's population is currently experiencing malnutrition, and the existence of the uncontrolled climate change will make these conditions even worse. The extreme temperatures and rainfall are factors that will make plants hard to grow. Therefore, to overcome this problem, it is necessary to increase the production of vegetables and crops, and that is why I'm really interested in doing this research. In this research, a solution containing water and nutrients in a liquid phase was converted into a mist phase using an ultrasonic mist generator. Ultrasonic mist generator converts the water into a micron-sized aerosol phase, and these water and nutrient microparticles have a smaller diameter than the diameter of the lenticels, stomata, and pores of plants' roots, so that water and nutrient particles can be absorbed by plants effectively. The ultrasonic generator also stimulates the stomata to remain open optimally, so carbon dioxide, the raw material for photosynthesis, can enter the plant quickly. Clouds of mist surrounds the plants, so the humidity level is high and the plants will not wilt. The red and blue LED lights replace the source of sunlight, and these lights are the most effective light used for photosynthesis. The selection of LED lights aim to increase lighting efficiency that LEDs also have a specific wavelength of light. This modified greenhouse is also equipped with an Arduino microcontroller to control the physical parameters such as humidity level. This is done to ensure that the plants get optimal humidity and exposure to microparticle water. Arduino microcontroller will adjust the humidity automatically. If the humidity is below 80%, the fan will be turned on and spread the microparticle water and liquid nutrition to all parts of the plant. If the humidity reaches 80%, then the fan will stop operating. To maintain the plant's photoperiodism cycle, this automatic system is only turned on for about 8 hours per day. Two experiments were carried out in this research to test the modification of greenhouse with microparticle water and nutrients, ultrasonic wave and growth lights with an Arduino microcontroller. The tests include the qualitative test, namely observing the habitus of lettuce plants periodically, and the quantitative test, including the germination initiation, the germination, and calculating the primary productivity by calculating the chlorophyll content equivalent to the value of primary productivity. And here are the results for each test. The qualitative test was conducted by observing the visual appearance of the plants within 2 weeks. Observations include the color of the leaves, the plant's height and thickness, and the plant's freshness. Here are the results for quantitative test. The following is the germination initiation data using 2 different treatment groups. It is shown that all of the seeds in groups with modified greenhouse has already started germinating after 32 hours, while the seed in control group started to germinate after 48 hours. And the following is the observational data on the growth of sprouts in 2 treatment groups. From this data, we can see that the growth percentage shows significant difference. The sprouts height in K4, the treatment group, has grown about 177.54% after 144 hours, while the sprouts height in K1, the control group, has only grown for about 55.96%. The primary productivity value is equivalent to the chlorophyll content of an autotrophic organism, and the following results from calculating the chlorophyll content of all treatment groups in the second week. In this table, it is shown that the chlorophyll content on the lettuce using modified greenhouse is 6.47, while in the control group it's only 2.43. And last but not least, I will state the conclusion for this research, which are the modified greenhouse with micron-sized water and nutrients, ultrasonic wave and growth lights with an Arduino microcontroller can increase the plant's primary productivity compared to the conventional planting system, and it can make the plants grow better than conventional planting system. To further optimize this research, I provide suggestion, which is conducting further research using a more significant number of samples over a more extended research period. Thank you so much for your attention, input, and consideration. Wassalamualaikum warahmatullahi wabarakatuh.